Hi guys, Mrs. B here. We're going to talk today about substituting into formulas. You would have done this in algebra with just any formula. So let's say you had b plus 3 and you knew that b was 1. You would substitute, if b was 1, then b plus 3. You'd replace the b with a 1 and get 1 plus 3, which was 4. Okay, but now we're going to apply that skill to area. So I want to find the area of this square. And I know it has side length of 2 centimeters. So we've got a formula for the area of a square, and that is A equals the side length L squared. So now what I'm going to do is I'm replacing that L with the value that I know. So this is 2 centimeters squared. So if I use my index law, I'm going to apply that to both the 2 and the centimeter to give me 2 squared centimeters squared. And what that means is I'm actually dealing in square centimeters. So if this is 2 centimeters, that there is a centimeter square. All right, and you might be able to see from this that the answer is going to be 4. 1, 2, 3, 4 square centimeters. And that also happens to be 2 squared. Okay, so we substituted when we replaced the L from the formula with the length that we knew. You might already know the formula for the area of a rectangle. So that is the area is the length times the width. That's only true if this is a right angle here, making it a rectangle, and a right angle here. So we've got 4 right angles in a rectangle. Now, tricky, I've got 2 values and 2 pronumerals, but how do I know what to substitute where? So I need to label my diagram as a first step. So it doesn't matter for a rectangle which one I call the length or the width. Usually we'd call the longest side the length, but it really doesn't make a difference. I'm going to call this L and this W. And that means in my substitution, now wherever I see an L, I'm putting a 2. Wherever I see a W, I'm putting a 3. So this becomes 2 times 3. Now, what did we do differently here to here? When I substituted into the square formula, I substituted the units as well. So that's not convention when we're doing area sum. We usually would just use the numbers and then add the units at the end. So I know the answer to this is 6, and now I'm looking at the units. So it would have been meters times meters, so meters squared. If it helps you to do it the whole way through, go for it. But if you can do this and just add the units at the end, even better. Okay, for a triangle, we have a new formula. So the area is half the base times the height. Now what's important with the height is it needs to be perpendicular, that might be a new word, so at a right angle to the base. So if we look back at this rectangle, this is actually perpendicular here. And if I were to cut this in half, we can see we've got 2 triangles that are the same. So that's how we get the area of a triangle formula. We're actually just cutting a rectangle in half. Now for this one it would be like that, where I've got these 2 are the same and those 2 are the same. Alright, so I've got half a rectangle, but which one's the base and which one's the height? So for a triangle, the base one's along the bottom, alright, or it's the one that has a perpendicular height attached to it. So I've labelled my diagram. Now everywhere I see a B, I'm going to replace that with a 6. Everywhere I see a H, I'm replacing that with a 4. So it's really important to show your substitution step. So this is half of 6 of 4. So half of 6 is 3 times 4. 3 times 4 is 12, and it's really important at this point we remember to add our units. So we had centimetres times centimetres, centimetres to the power of 2, or centimetres squared. Okay, one of the last shapes I'm going to talk about today is the trapezium or trapezoid. It does not have to be a symmetrical shape. I've kind of drawn it symmetrically, but it could look like this. So basically it's a quadrilateral, meaning four-sided shape, that has one pair of parallel lines. So as soon as you have two pairs, it's a parallelogram, but with just one pair of parallel lines, we have a trapezium. Okay, and the formula for the area of a trapezium is A plus B over 2 times H. What the heck does that mean? So the A plus B is over 2 is taking the average of the top and the bottom. So I'd call one A and the other B. Usually we call the smallest one A, doesn't really matter. And then the H is perpendicular to the B, the base. Okay. So I can now substitute here. What you might have noticed in this diagram is I actually haven't been given units. So we'll talk about what you do with that in a moment. So I'm substituting a 2 for A, a 3 for H, and a 6 for B. And I get 2 plus 6 divided by 2 times 3. All right, now if I imagine, because this is one fraction, there's an invisible set of brackets around it, I've got to do that first. So 2 plus 6 is 8, 8 over 2 times 3. 8 divided by 2 is 4 times 3, which equals 12. Now we've got the problem. We don't have units. We don't know what they are. But we do know that they're square measurements. So I'm not doing linear measurements. I'm looking at space in 2 dimensions. So it's going to be a square unit. So what I actually write is units squared. And that means no matter what the units are, I'd still get an answer of 12. Now that brings a really important point. These measurements have to be of the same type, so I couldn't do this if one of these was in centimetres and the other was in millimetres. I'd have to convert them both to be the same at the beginning.